Hello, welcome to our second video in our R training. In this video, we will cover how to summarize and filter data. We will be using a sample data set that mimics your VectorSurv data. So we encourage you guys to follow along and use the sample data as we use it. And the sample data is part of the VectorSurv R package, so it should be accessible to everybody here, regardless if you have an account or not with VectorSurv. So in the last video, we learned how to create an RMarkdown file, and that's where we will start in this video again. As a reminder, RMarkdown allows you to create dynamic analysis documents or reports that combine outputs such as figures, as well as any other text that you wish to include in your document. When working in RMarkdown, you can run specific code chunks sort of locally inside your environment, but as well, you can knit the whole file and turn it into a Word document or a PDF or an HTML. And so just as a quick refresher, we use either, if you're on Mac, Command-Alt, or if you're on Word, Control-Alt-I, and that creates a chunk in R right here, as you can see. And then if you were to wish to knit your file and sort of integrate your code chunks into a document, you would use this knit button up here, and you can even use a little drop down. You can see that there's different types of documents to knit your code into. And one thing that it is important to note is that when it knits linearly or chronologically. So every chunk of code must have, for example, if something is defined in a chunk of code that comes before another chunk, then that's the way it has to be when you knit the document, meaning that if you were to define a data table called collections on your first chunk, which is equals something, and then if you were to refer once more to collections down in your next chunk, this would only work if collections was defined before the second chunk. And so let's start with our blank document. This is our blank R Markdown. And so one thing to note is that you want to make sure that when you save this document, that you have saved it in an appropriate file or folder that you can access on your computer, that it will be known as your working directory. So we have already installed the VectorSurv R package in our previous video, so we do not need to reinstall it, but we do need to load it in order to access the functions that it has available. So let's go ahead and do that now. So Control-Alt-I, and install my library. VectorSurv R. And so, and also once more as a refresher, Control-Enter here to run that. And as you can see, it has installed, it has essentially loaded all the functions necessary that come with this file. Now, if you do not have VectorSurv R installed, it will tell you that this package does not exist when you go to call it, like to load the library. In that case, you will need to install VectorSurv R. And it's recommended that you do this in the console so that you don't have to reinstall every single time you run your code, which is very time consuming and a lot of processing power is used. It's not good practice. So to do that, you would, and I'm not going to run it because I already have mine installed, but for here, you do install packages and you would type the package and then enter, and then that shall install it to your system. And then after you've done that, you will still need to load the library up here in your code. And it's important to note that similar to how things are chronological in codes, libraries are also chronological. So if you were to load VectorSurv R in a chunk way down at the bottom of your file and you call functions for it above that, it will not recognize those functions. So it is recommended that you load all your libraries at the top of your document, and that way you just avoid any issues that might arise. Now, however, if you do wish to include your installed packages in the code, for example, maybe you're sending this to someone who has never used this, these libraries before, and it's good to have you need to run this installed package beforehand. You can still include this in your code without having it run every single time that you knit your file or run any of your chunks. You would do that by commenting the code out. And so like here, I'll show you guys, if I was to run this would, every single time I would knit my file, it would reinstall VectorSurv R. However, maybe you don't want that. And so you would, preferably in this case, you can comment it out with a pound symbol. And that here, you see the code gets grayed out and it will ignore this code And that way, somebody that you might be sending the file to could see this and just easily uncomment all this, run that their first time, have their packages all installed, and then load the files. And then they would preferably or ideally comment this out afterwards. And that way, that would avoid having it rerun every single time. Now, when we install our VectorSurv R package, we also have installed a whole bunch of other packages that use functions that this package relies on. Now, it's important to note that those are installed internally within the package, meaning that just because that even though they are installed into your system, you still have to load those packages in order to use their functions outside for your own purposes. And so if we want to use those, we are going to have to load them, and we're going to go ahead and do that now. And we'll do that in our Markdown file and not in the console, because we wish to, every time we run this, we wish for those functions to be available to us. And so I'm going to go ahead and load the necessary packages, and then I will put a little comment after each one showing kind of giving a general like what this package does. And so as you see here, as I'm typing Lubridate pops up, and this is because I have Lubridate installed in my system as a package. Lubridate should get installed in the system when you install VectorSurv R, but there are times where you might have a package that, again, like you did not get installed when you install one package, right? So if you are to type in Lubridate and run it and it says Lubridate's not found, you will have to, somewhere up here, install packages Lubridate, and then you should be good. And so Lubridate is going to be used for our purposes. It helps you manipulate date values. We're going to use it to get the disease week, and then from that, the disease by week from our collection date. So this is more so a date processing package, which has many other very helpful things in it, but that's what we're using it today. The next library we're going to load is tidyverse, which is sort of a suite of libraries. It includes things that we use for graphing. It uses things for filtering, selecting columns, etc. Many, many, many things. Very useful, very popular package. So that's tidyverse. And after that, we will use the knit-r package, and that's going to help us create tables, more so customizable tables. And then from there are two other packages we will be looking at. These ones are, I'm going to put it as they're much more interactive type packages. And so these are sort of, these will create objects that are HTML objects only. So in some ways it's HTML only, or more so more interactive things. For example, ways that you can interact with your charts and your graphs, so you might be able to mouse your mouse over a point on a chart and it will tell you what that point represents. And those are things that are really HTML only. If they were to be put in a Word document or a PDF file, they would become stagnant and lose some of the interactivity. But so for those libraries, there's one that's known as data tables. And this gives you essentially interactive data table charts. And then the next one is going to be Plotly. And Plotly allows you to have interactive graphs. And this will allow us to, whenever we plot something using the ggplot2, which is a graphing library that exists within tidyverse, Plotly will then allow us to render that graph as something that is an HTML object that we can interact with, we can select, we can zoom in on. And so I'm going to run these real quick and see if any of these show up as not existing. And if they do, we'll have to reload it. Nope, it looks like they're all there. That's good. And now that these are loaded, we can get on going to the sample data, and we can look at the sample mock data sets that will be mimicking the type of data that you will retrieve from VectorSurv. And it will give you the opportunity to sort of follow along with us as we take that data and chart it and plot it and process it. So the sample data is included inside of the VectorSurv R package. And you can access it. It has two names. There's sample collections and sample pools. And so you type sample collections, you'll see right here that VectorSurv R, and this means that this is coming from the VectorSurv R package. As you can see here that this contains not a, it's different from what you would get if you were to send a request to our get collections, because it does not include every single bit of data that our data system contains, things like who identified it or with exact name of the site. This is a sample data that is derived from real data that contains all the necessary components to use VectorSurv R functions and the necessary parts to analyze and look at the data. However, it's not real data. And a lot of these things have been masked for privacy reasons, but all the essential data or essential information is there. And we also have sample pools, which is the same similar thing to sample collections, just in this case, it is using pools. For this training, we're going to be focusing on sample collections. And in case you guys just saw, I use this head function here. This is a commonly used in coding. It is simply to give a first short chunk of the data. So the first, taking a peek at the top 6 parts, top 6 rows of data in R. And that's generally convenient as opposed to loading all the data at once. Of course, given that R has in this nice sort of setup and has a nice scrolling setup here, you can do that if you wish. And you can see there is quite a bit of data, but and it comes from it spans over a couple of years, and so we'll be using this data to, we'll basically be investigating this data as for training exercise today. One thing to note is that if you ever have an instance with working with sample data in this package and you change the sample data or summarize it, you're not changing the actual data in the package, you're changing the copy of the data that you have on your own system. So we're going to jump right into how to select, filter, and summarize data. Something that is important is this operator right here. And this is known as the pipe operator. And this will allow you, this comes from the tidyverse package, and it allows you to send data into a function. And it is very convenient for readability, and it is very intuitive. And we'll show you just how intuitive it can be. And important to note that there are many, many ways to do things in R. You do not have to use packages. For example, if I was to do here sample collections, I put the square brackets, and then I put a C indicating that I want a vector, and then I put parentheses, and I would like to select, say, if I look at my data here, I just want to select collection ID. I could do that, and then if I were to run this, it would just give me the row of collection ID. So there are many, many ways to do this in base R. It's not the most intuitive way to do it, or the most, if you were a beginner, it is not necessarily going to be like the easiest way in some ways, or rather there's a lot of sort of caveats sometimes using base R, and you could also just as easily use the select function. So using a pipe operator, which tells you to send collections, this data into the next function. You can select, and we want the select from the dipLOR package. So this is something that is important to look at. Sometimes you will have multiple packages. In this case, it's going to know what it is. But so this is saying select data. And since we've already sent this data in, we don't have to reference any data columns. And we could say, you can just type out the plain text of the column name. So collection ID, species, display name, and then maybe move on. So this here will give you a subset. And then from there, you can also subset other things. There's multiple functions within this tidyverse package that allow you to take slices of data, take segments, even take certain parts out of groups of data, and all kinds of things that you are able to do. In this training, we're just going to focus on select, filter, summarize, and group by, but those are going to be the main things that people will be using. So here this is just simply selecting. And one thing to note is that running this here does not change sample collections by any means. This is the same data. This right here is just the output of this call. And so if you wanted to have this saved, you could say example slice, for example, and then you would want to essentially define this output to a new variable. And then you can see here, sample slice that we just created shows up in our global environment, because this is a piece of data now, and this is going to be what we just created. And so this is where sometimes people will be doing an analysis or doing a rundown of data, and they will not define the variable, and then things get lost along the way. And it's like, wait a second, that's supposed to have changed, but it didn't. It is also important to be aware that you can reload things, but like when you change things, you are changing components of the data itself. So you might run into issues where you change a column name and then run it in a function, and then that function doesn't work because that function is dependent on the name of that column. And that is why we recommend, if you are to rename columns, that to do it with caution and not do it with the raw data. And so this is how you select, and this can be done with any of the names in this function. And so that's great and that's useful, but more useful is filter, in my opinion. And all these functions that I'm showing can pipe into each other, meaning that like this pipe operator here, as I send this to select, I could then send this select to a filter function and filter on this particular output. And so this kind of allows us to have almost a sort of like a flow of how you see the data sort of gets piped from one function to the next when the output becomes the input. And so if we were now going to here sample collections, want to filter, we do filter, and then it's very similar to select. You want to locate like what you're trying to filter on. I will do species display name. In R and in a lot of coding languages, you use equal sign to assign a variable. When you want to actually reference a particular value of that variable, you need to use the double equal signs. So here we'll do double equal, and I'm going to Felix Salas. And then I'll do one that is multiple filters. So say I want to do trap acronym. And at any time when you guys are looking at your data and you're wondering, hey, well, I want to filter on trap acronym, but I don't know all the trap acronyms. And if I just look at the data and scan through all of it, I might not see every single option. What you can do is run your data, and then you can use this $ operator to reference a single column if you want. And this is just a way that when data frames, we can reference singular columns or just singular point aspects of data. We go in here, oops, trap acronym. And obviously, if I was to run this, we get every single one that is within this data. And we just want to know the exact ones that are available as options. You can put unique in front of it. And that will show you all the unique trap acronyms for this data. And this can be done for any variable in data. And so as you see, we gravid locker CO2. So maybe we want then to filter for Tarsalis mosquitoes that are in gravid and in CO2 traps only, if that's what we're looking at particularly. So to filter for multiple things, the way to do it is using the in operator. So it's this %, and then you can say you create a vector, and then you can do the thing to filter, essentially filter for when species are Helix tarsalis and trap acronyms that are within these two acronyms. And so we would run this. We'll see that obviously we have much less data here because there's less data. And you can see that all the species are Tarsalis, and the only traps are gravid and CO2. And so this is a helpful way that if you ever want to look at a very specific area of data or compare things by month or compare things by week, or other aspects, filtering and just sort of going through the process of that can actually not be that complicated. Of course, once again, this is not changing sample collections. It is simply giving you the output. And from there, yeah, that's simply that's the filter function. You can also filter on numerics if you wish. You could say, you know, we want num count to be less than 5. And you run that, then you will, you know, once more of the data has decreased, and all these that are better less than 5 will show up. And so there's a lot of different ways you can filter your data, but it can be very useful for identifying specific points. And so that's filter, and then before that we did select. And so now I will show you guys some group by and then general summarizing. And so group by and summarize kind of come together. So let me real quickly. But before we get into group by, we might want to understand, like, what are we grouping something by? And so, like, we were to do something like collection date, it might not be that useful in terms of our actual data. So we were to do sample collections, and then we want to group by, how about collection ID, and I can also use collection. Let's say if we wanted to get sample collections and we wanted to get, for every group by collection day, the total amount of mosquitoes collected. So we don't, regardless of the sex of the mosquitoes or the species, we just want to see the total count recorded for each collection date that we have available. And so to do that, you would group by collection date, and then you want to summarize. And then when you summarize, in this case, we want to have the total sum of mosquitoes. So we would do sum here, and then we can do num count. You run that, and so you see it's for each collection day available in our data, it is essentially summed the mosquitoes up. One thing to note about the sum function is that if you do have an NA value in your data, it does not matter what else is in the data, the sum will be NA. And so that can cause a lot of misleading results. And so a way to make sure that doesn't happen to you, especially say you do a summation on month and you're like, well, no, there was at least one collection this month. Why is it NA? It might just be that there is an NA in your data. You can either remove that, or a nice way to do that without removing that is to simply in your sum function, NA.remove. There's an argument, and you set that to true, and that way any NA values that will essentially be ignored in the summation. So if you had one NA and you had 5 data points and one of them was an NA, you would still get the sum of the other 4. And that's as important, because you don't want the issue to show up. And obviously this isn't super useful. I mean, you can, this column name, you can rename what you summarize within the summarize function itself. So if I was to say, that will rename it for you. This only works on the output that comes from this diplar function. And note also that when we group by something, we are, in this case, group by, we are removing all the other parts of the data. We're sort of reducing the data in that way. And there are ways using these functions to keep all the data points or keep some of the data points. But because we are trying to get just the total sum, it's not important. The species is not important in this case, because we're just looking at all the mosquitoes in total that were collected. So though, as you can see, it's not necessarily, collection date itself may not be all that, that's very large, it might not be all that useful. You might be more interested in, well, what does it look as by week? What does it look over, if I wanted to compare 2017 to 2016 and look at the breakdown of what mosquitoes I caught during, like what mosquitoes were caught during those 2 years. per each bi-week. For example, I want to see if maybe things, maybe the peak started earlier this year, then it's more useful to group by things like bi-week or disease week. And so we can do that using the lubridate package. And this is mostly because, collection date useful, not necessarily the most useful, or not necessarily what everybody wants. Some people want their data by month. And with lubridate, we can do that very easily. So the lubridate function has two functions. One is epi year and one is epi week. We don't need to use the epi year function because the surveillance year in the data is already the epi year, the epidemiological or the disease year. And so how you would want to redefine this in your actual data. So say we want our sample collections to have a new column named disease week or dis week. You would do sample collections. If you want to initialize a new column, you can use so here this $ allows you to reference singular columns. If you put a new variable that does not exist, that will create a new column within this data. So say I do this week. And so I would use the epi week function, and then I would do sample collections, and then I would like to reference my collection date here. And then when I run this, sample collections again, and I look at this, and you can see here in my environment, sample collections just showed up in my environment. And that is because by modifying sample collections in my local environment, I've just created a copy of the data. And so because we cannot modify sample collections in the actual package, it creates a copy for your own local uses. So you see here, if I go to the end, now I have disease week available. And if I wanted to also have the bi-week, it's very similar to how to get disease week. You would just have to take the ceiling. So you're taking the upper limit. You need to take the ceiling of the dividend of 2 here. So every week. So in this case, 27, disease week 27, or so let's do disease week 14 because it's easier math. You divide it by 2, it'd be 7, so it'd be bi-week number 7. For like 34, you would divide by 2, which is 17. So bi-week 17, and then so on and so forth. Even if you divide by an odd number, it's going to take it to the ceiling. So see a bi-week and disease week. And so this is a very simple way to get these values within your own data. And then from there, you can look at things using different increments. So now that we have this, and this is saved within the sample collections, which is local now on our computer, we can do some grouping and some summarizing. And so say, similar to above, we have this sort of Tarsalis and then traps. Say we want to now look at the total number of, I would say we want to look at the total number of mosquitoes per bi-week. Just do a simple one to begin with. And so to do that, and let's say actually we can even filter before if we wanted to, but let's just do it now just for bi-week. And one thing to note is that if I was just to type bi-week in here, just group by bi-week and then summarize and then do some num count like this, you're going to notice that this is not very useful because there's more than one bi-week labeled 1 in our data. If you look at our data, this is where it comes to where it's very useful to understand the structure of your data before you start doing analytics. You see here we have year 2016 and year 2017. So summing up all the mosquitoes per bi-week is not going to be helpful from an analytical perspective. But if we also group by surveillance year, and then we also group by bi-week, and then we summarize on that, now we end up with something that can be a little more useful. So we can see for each one, we have a total, and these can be broken down further in group. There's really no limit to what you can group things by. It's recommended that you group things by character factors, so things that you don't really want to group things by numeric values. It does not make sense. But we can also, in this case, group by species display name, which adds yet again another dimension to the data, another layer. But then it breaks it up in a way that we can visualize later on. And so you see here, this is just for 2016, the first week. And so this is the breakdown of what was collected for the first bi-week. And then next time you see a continuation of the data. Which one? And so summarize, you can also summarize on mean and medium if you wanted to. So like say you wanted to know the medium number of, the average number of mosquitoes collected from certain trap types. We could do that. If we really wanted to, we could do that. If you really wanted to know this, you could do group by trap acronym, then summarize. You want to know the average number of mosquitoes, so you would do mean in this case. Oh, my light went off. You would do mean in this case, and then this would give you the average number of mosquitoes overall in your entire data. So one thing to note when you are grouping by things is to keep data dimensionality in mind, keep the fact that you have multiple years in your data in mind, and that there's sometimes you might have a lot more variability than you know, and summarizing something is not always going to be useful. It can be when you know what you're looking for, and you also are aware of what the caveats of your data are. But one thing to note is that there's many arithmetic functions that you can use to summarize data. And for all of these functions, I do recommend, if you are curious, to, as previously noted in our previous videos, to really want to know more about them, to use the question mark notation, and then from there reference the official documentation, because oftentimes the official documentation, so here it would be in this package, gives you a lot of very useful examples and a ton of different functions that you can use for this summarize function that you would use in your own analysis or your own studies. In the next video, we'll go over turning the summarize and filter data into tables and charts that can be useful in a report for any data visualization purposes, such as presentations or anything that you could put on your agency website, for example.